today's problem from LPP, and this problem is taken from your previous year university paper. Okay, and here an incomplete simplex table is given, and this is of maximization problem. Okay, and we have to give the following answers. The first problem is complete the objective row and the table. Okay, we first complete the objective row. This is given by the row of Cj, and in this table it is given that in the basis the vectors are a5, a6 and a7. Okay, and since the vector are a5, a6 and a7, so we first complete three standard bases a5, a6, a7. This is given by 1, 0, 0, 0, 1, 0, and this is 0, 0, 1. Okay. Now it is also given that these three negative values zj minus cj are 0. Okay. So here must be the cost coefficient are 0. Also it is given the cost coefficient here 0, 0 and 0. So we write this is cost coefficient of a5, this is a6 and this is also a7. Okay. Now here the negative values are -4, -1, -3 and -5. And since we know that Zj minus Cj, this is equal to Zj means this is Cb dot Ai. Ai means this vector. Okay, minus Zj here. Now for the first column it is given that 0 into -4 plus 0 into -3 plus 0 into 8. This is obviously 0. Minus 0 minus Zj is, sorry, this is Cj, not Zj. Zj is not here given, sorry, Cj, this is given by -4. Okay, and clearly Cj, this is equal to 4 for the first column, that is this is C1 and this is also C1. So we write here C1, this is equal to 4, and using the similar argument here we write this is 1, here we write this is 3 and this is 5. Okay, so we first complete the objective row, and we already complete with objective row, we complete the table or the first simplex table. So we answer here the complete the objective row and the table. Now for the second answer, we have to write down the LPP in standard form. How to write down the LPP in standard form? Since the variables are used here xi, x5, x6, x7, it is given in the table. So we write the LPP in standard form as, starting from this we get this is -4 x1 plus 6 x2 plus 5 x3 minus 4 x4, this is x5, this is 0 x6, 0 x7, and this is given by equal to b, which is equal to 20. Okay, and similarly we write for the second row, this is 3 x1 minus 2 x2 plus 4 x3 plus x4, this is 0 x5, this is x6 and this is 0 x7, this is equal to, it is given by 10. So this is 10, and the third row, that is the last row, this is 8 x1 minus 3 x2 plus 3 x3 plus 2 x4 plus 0 x5 plus 0 x6 plus x7, this is given by also 20. Okay, we with all of xj greater equal to 0 for j equal to 1, 2, 3 to 7, right? And here we have to write the objective function which is given from the first row. This is given by max z. This is equal to 4x1 plus x2 plus 3x3 plus 5x4 plus 0x5 plus 0x6 plus 0x7. Okay, and this is the standard form of the LPP. Okay, and now we have to find, this is the answer number 2, and we have to write down the actual problem. How to write down the actual problem? Since here we use 3 slack variable x5, x6, x7. So original problem looks like, we write here, original problem is max z, this is equal to 4x1 plus x2 plus 3x3 5x4. Okay, now the first constraint is given by minus 4x1 plus 6x2 plus 5x3 minus 4x4, and this is less equal to 20. We cannot write here the slack variable. And the second constant is 3x1 minus 2x2 plus 4x3 plus x4. This is less equal to 10. Now 8x1 minus 3x2 plus 3x3 plus 2x4 less equal to 20, with xj greater equal to 0, where j this is equal to 1, 2, 3, 4. Original variables only 4 variables, x1, x2, x3, x4, and this is our answer number 3, and this is our actual problem. Okay, now we have to find out the diverging vector and entering vector and write down the next table. Okay, how to find diverging vector and entering vector? Since the most negative net evaluation is minus 5, so it indicates that this is entering vector. Okay, so entering vector is A4. Here we write the answer number 4, entering vector is given by A4. Clear? Entering vector is A4. Now we find the mean ratio for calculating or for indicating the outgoing vector or departing vector. How to calculate mean ratio? Here we write another column. Here mean ratio. Okay, mean ratio is given by 20 by minus 4. Since this is negative, so we cannot calculate the mean ratio for this row. But 10 by 1, this is 10 by 1, this is equal to 10, and 20 by 2, this is also equal to 10. And since there be 2 10, that is a tie arise here. Okay, so we can choose any one of the row. We can choose this row, second row, that is A6 may be entire in the basis. Sorry, A6 may be departing from the vector, or here is also 10, so we may choose A7 as a departing vector. Okay, but if we choose A7, then the key element is 2, and if we choose A6 for the departing vector, here 1 is the key element. To calculate easily or to calculate the next table easily, we take this row as the key row. Okay, and this element is the key element. So we take here, this is the key element and A6 is the departing vector. Okay, so we write here, and here we indicate the mean mean ratio, mean of mean ratio. Okay, and here we write departing vector. Is given by A6. Okay, now we calculate the next table. So we first draw a simplex table to write down the next simplex table of this problem. Right, this is next simplex table we already drawn here. Now we first fill the basis column. Here A6 is departing vector and A4 is entire vector. So we first put here A4 in place of A6 and other vectors are same. This is A7 and this is A5. Okay, and now the cost coefficient corresponding to the basis is 0. Here is 0 also, and corresponding to the cost A4 we must put the value of the cost. This is 5. Okay, now here key element is 1. So there is no need to calculate for the key row. Okay, and key row becomes unchanged. We write here the variable. This is x4, this is x7, this is x5, and this row is unchanged. This is write as same 10, 3, minus 2, 4, 1, 0, 1, 0. Okay. Now to convert it into 0, that is it into 0, here we make a operation which is given by, this operation is given by R1 dash, this is equal to R1 minus, this is the new second row, this is R1 plus 4 R2 dash, R1 plus 4 R2 dash, so it is 0. Okay, now we start from the first. This is 20 plus 4 into 10, so this is 60. This is minus 4 plus 4 into 12, this is 4 into 3, this is 12. That is minus 4 plus 12, this is 8. Right, this is 6 minus 2 into 4, this is 6 minus 2 into 4, this means minus 2. Because 6 minus 8. This is 5 plus 4 into 4. This is 16 plus 5. So it is 21. Right. And this is 0, 1 plus 0 into 4. This is obviously 1. And this is 0 plus 4 into 1. Sorry, this is 4. And this is 0. Okay. So this is the first row. Now for the third row, we make a calculation because we have to convert 2 into 0. So we make a calculation or operation. This is R3 dash is given by R3 minus 2 into R2 dash. Okay, so we write here first, this is 0. Now from the first we get 20 minus 2 into 10, this is 0. 8 minus 2 into 3, this is 2. Minus 3 minus 2 into minus 2, so this is 1. This is 3. 3 minus 2 into 4, this is 3 minus 8, so this is minus 5. And this is 0, and this is obviously 0. This is 0 minus 1 into minus 2, this is minus 2, and this is obviously 1. Now we fill the net evaluation row. Net evaluation row is given by 0 plus 15 plus 0 minus 4, this is 11. This is clearly minus 10 minus 1, this is given by minus 12. And this is 20 minus 3, this is given by 17. This is 5 minus 5, this is obviously 0. This is 0. And this is also 0, but this is given by 5. Okay, since here is also a negative net evaluation, so this is not the optimal table, that is we cannot reach the optimal position of this problem. Okay, but our problem, or in our problem, it is given that we have to only write down the next table. Okay, so this is the next simplex table of the given problem. This is your complete solution of